morning, good evening, good afternoon, wherever you are. My name is Vishnu Dutt, and today we are into our session number two of IPv6 from scratch. Okay, and here is the agenda of today's session. Today's agenda is going to be really interesting. First thing first, we are going to talk about what we discussed in yesterday's class. And then we will be talking about an interesting logic. Believe me, if you get this logic, almost 90% of the problem of subnetting or this IPv6 address is resolved. So put your best, right? Be concerned. Put your all the concentration into this topic in interesting logic, right? We will be talking about how IPv6 addresses are distributed, and it is going to be an interesting discussion. The reason is, means you can presume yourself IANA, which is the highest authority which distributed all these IPv6 address, and you will get a chance to think from its mind how it is going to distribute this huge number of IPv6 addresses. We will be talking about one interesting address which is known as GUA. What is the meaning? I will be talking about it, and little bit about subnetting. What exactly the meaning of linked local IPv6 addresses. And I have seen many people who are so confused about layer 2 and layer 3 multicast. Before starting IPv6 multicast, I would like to explain these two concepts, because multicast concept is very, very important in IPv6, and the reason is because we do not have any broadcast in IPv6. Remember, I mentioned you that while developing this new protocol, next gen protocol or IPv6 protocol, these people removed whatever was unnecessary, right? Because they had the experience of IP protocol, what was wasteful there, so they just removed it. Then we are going to talk about where are we, and then an interesting fact, if time permits. So this is going to be the agenda of next 1 hour and 15 minutes. I'm just asking your 1 hour and 15 minutes. If you give them to me, I'll make sure that these concepts, I promise you this, that these concepts are going to be with you for a long period of time. Having said that, let's move to our first board, where we are going to talk about what we did in the last class. It was very simple, right? We had 128-bit IP addresses, although we discussed a little bit of history of IPv6. I think you all know about it. And then we had this great looking address, and Anjali and Rahul guided us to shorten these addresses. And there were just two rules, two simple rules. Rule number one was just remove all of these leading zeros, right? Not trailing one, leading zeros. And you can reduce your address. And then basically wherever you see the consecutive zeros, rule number two, just replace it with double colon. You can't replace it with two double colons, means if you see multiple consecutive zeros, right? And we discussed about it. Just have a look at the previous class. You will get to know that why can't there could be two different columns. There should be only one double column, right? This was the only two rules. Although there are some more, right? For example, RFC says that instead of writing everything in capital letters, you should write all these letters like A, B, C, D, E, F in small case, means like this. Because some operating systems are case sensitive, so make a habit of writing in small cap. I really don't have this habit, so sometime I write in capital, sometime I write in small, but it is going to be very good if you make a practice, or if you make up your mind that you need to write always in small case. The other thing is, what is going to happen if you have two consecutive zeros, right? But not once, means same number of consecutive zeros, but not once, but in twice in address. For example, instead of this is all zeros, what would happen if this is maybe F? It means that we have two number of consecutive zeros here and zero, which are same, right? This hex state number 1 means hex state number 1, hex state number 2, all 0, hex state number 3, hex state number 4, all zeros. If I say this is 3 and this is 4, all the things 3 and 4 are this, but presume, right? Then in this case, where should be the double colon? Here or here? You can decide, you can choose it, but RFC says that is going to be great if you put a double colon, right, for those consecutive zeros which are coming, you can say at the start, not at the end. So this is at the beginning of the address, and that is why we will be putting double colon right here. As simple as that, right? Now, let's talk about what we are going to discuss in this class. So this was just the only recap with some more flavor of rules. That is it. Now we all understand IPv6 addresses, but believe me, there is one interesting thing which you all should understand, and that is the interesting logic. So why we are talking about this interesting logic, right? Why there are so many numbers? Do not worry about this number. These are just in decimal number system, countings from 0 to 999. Not a big deal, right? But the problem which I got was that there was a statement written in a book which I am following. I can definitely share the book name with you, and it has written there that 2000 :/3 is the only IPv6 address range we have right now for everybody, and this is a huge range. And this range is actually 1/8 of total IPv6 address range. Try to think about it. If I say that I have a pizza, right? And if this whole pizza is equal to my IPv6 addresses, and if I distribute or if I cut them into 8 equal pieces, then this piece from here to here, it is going to be 1/8 of this pizza. And this number 2000:3 is representing 1/8 of my total IPv6 address range. Then what exactly the meaning? How can I come across that 2000:3 is representing this piece of total IPv6 address range? People say, that book says that this is the only range which we have, along with some other IPv6 addresses like multicast. Interesting, right? So to understand only this statement, because this is going to be very crucial to understand these subnetting, right? And if you have a little experience of IPv4, this is going to be easy for you. Otherwise, no worries. We start everything absolutely from scratch, right? So I have been into this industry from last 16-17 years. Believe me, I never put attention to this statement till couple of weeks back, because now I had to read IPv6 to teach you, right? So this is one of the most interesting thing which I read in overall IPv6, right? So what is going on here? See, suppose we have numbers from 0 to 999. I'm just talking about right now decimal number system in which you all are proficient. If I say I have numbers from 0 to 9, how many numbers these are? These are 10 numbers, right? You can count them. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 means these are 10 numbers, right? This is why the decimal number system. What if I write 0 to 999? How many numbers I have? I have 1000 numbers. So there should not be any doubt with respect to this fact, right? So now here is a simple assignment for you. Just do this mathematics in your mind. I have these 1000 numbers, right? In case of binary, in case of hex, we call them addresses also, right? So you can tell we have 1000 addresses if I would like to be more precise. if I have 1000 addresses, how I am going to partition them in 10 different pieces? Simple question. If I have 1000 addresses, how I am going to divide them in equal pieces or 10 equal pieces, right? And every piece, as I am saying equal, every piece is going to have the same number of addresses or numbers. And then you must be thinking, Mr. Vishnu, very easy, right? And suppose I add one more thing onto it, and then you need to distribute them to 10 different people, and then it is going to be easy, right? Here is my person number 1, right? And how many numbers he is going to get or address he is going to get? Starting from 0, 1, 2, 3. So this column, whatever I have written here, from 0 to 99, 100 numbers will be allocating to, or addresses will be allocating to this guy. If I talk about another guy, because there should be 10 guys, which are owner of now these 10 pieces, the second guy will be taking the addresses starting from 100 to 199. Third guy, fourth guy, fifth guy, and so on. As simple as that, right? So what we have done, we have just divided the entire 1000 number space or address into 8 different pieces, which you can see in this pie chart also. Sorry, not 8, extremely sorry, 10 different pieces. And every piece, for example, if I talk about part 1, it is comprised of numbers from 0000 to 099. Then you must be thinking, Mr. Vishnu, why you are writing 0 as 000? Because I would like to mention here that the counting will stop at 999 starting from 0. So it would be great if we have the same, means a standard, some standard is going to be there. That is why I'm using these 3 characters to represent, right? And of course, if I want to write 1000 things or 1000 numbers in decimal, minimum I need 3 different characters, right? Which can take position from 0 to 9. And that is why 1 character, 2 character, 3 character, right? And every character can take 10 position. It means that it can write 1000 numbers. As simple as that, right? Similarly, if I talk about binary, if I have, because 1 character can take only 2 positions, ones and zeros, right? And if I have 2 bits, I can write only 2 to the power 2 numbers from it, which are 4. If I have here 3 characters, I can write 10 to the power 3, which means 1000 numbers. As simple as that, right? Again, I start everything from decimal so that you get to the core. I think you get this. One more thing I would like to tell you here is, consider any part, right? We are having 10 parts of 1000. This is 1, this is 2, this is 3, this is 4, this is 5, and so on. This is my 10th. And concentrate on the starting digit. This is changing from 0. Then in the next part, it is going to be 1. It is going to be 2. It is going to be 3. Then 4. Then 5. And so on till 9. It is changing its position from 0 to 9. And of course, a character in decimal number system can take 10 different values from 0 to 9. And that is why we are able to get these 10 different parts. It means that the starting digit is representing, right, that part, right? With 1 digit, we can have 10 different combinations from 0 to 9, and that is how we are getting these 10 parts. It means that in decimal, if we have 1 digit, I can have 10 to the power 1, which is equal to 10 different parts. If I had 2 digits, then I can partition them into 10 to the power 2, which is equal to 100. Just think about it. Really interesting, right? If you don't get it, I would say just rewind this video. When you revise it, it is going to be interesting thing. Now let's come back, and we will doing the same logic, but now this time in binary number system, right? Now we have question from Mr. Vignesh. Thank you so much, Mr. Vignesh, for asking this question. Please go ahead.
So the address 2000:/3 range, you told like 1/8 of this address is the total IPv4 range, right?
Yes.
So
I haven't explained that. To explain
okay.
this, I have just explained one interesting logic. Right?
Okay.
But
Okay.
I haven't explained that. Believe me, I am going to explain this. So first I have explained the logic behind decimal number system. I will explain the same logic in binary, and then we come to hex. Right?
Okay. Fine.
Don't
Yeah.
worry, it is not complete.
Yeah. Okay.
Perfect. Now, let's talk about the same logic in binary number. And I have taken a very simple example of only 5 bits. With 5 bits, how many numbers I can write? With 5 bits, I can write only 32 numbers. You all know about what are those numbers. Those numbers will be starting from 00000. Then it is going to be 00001, right? Then it is going to be 0010 and then 0011. This is number 0, this is number 1, this is number 2, this is number 3. And if you make all the combination, at last when we reach to 15, right? At last when we reach to 31, it is going to be all ones. I think you all know about it, right? So from 0 to 31, it means that these are 32 numbers. Starting number is this one, ending number is this one. Simple. Now I am giving you one little exercise which you can do in your mind. So 00000 to 11111 means 32. You need to divide it into 8 parts. Every number is an address. Suppose, although it is not a 32-bit address, where we are understanding all the things from small numbers. Take it. Means 32-bit you need to divide into 8 different parts. And you must be thinking, Mr. Vishnu, again it is easy. If it is 32 and if I need to divide it into 8 equal parts, every part is going to contain 8, such that 4 into 8 is equal to 32. Simple mathematics. But what are those 4 numbers going to be? Right? Those 4 numbers are going to be, the first part will contain number from 0 to 3. The second part is going to contain number for 4, 5, 6, 7. Third part will be 8, 9, 10, 11 and so on. And that is what I have written here. This is my part number 1. Okay. This is my part number 2. This is my part number 3. Part number 4. Part number 5, 6, 7 and 8. As simple as that. Right? Really simple. Now, just try to understand. If I talk about this, I have written some numbers from red pen and some from blue. See it in any individual part. If I talk about part 1, these 3 numbers are constant. Same. If I talk about part 2 also, these 3 numbers are constant. Same. In that part, I'm not talking that 000 is equal to 001. No, in that part, the starting 3 numbers or the starting 3 bits are same. Here also, here also, here also. What's going on here? Right? The interesting thing which is going on here is, try to understand this, that we were talking about a number which is 32-bit long, right? Sorry, not 32-bit long, which is 32, right? And we need to divide into 8 different pieces. If we want to divide a binary number into 8 different pieces, how many numbers we need? How many bits we need to divide it? We would need 3 bits because 2 to the power 3 is equal to 8. See, we did exactly the same thing. We were dividing 1000 into 10 equal pieces, right, in decimal number system. So how many character we need? Only one character we need, which can take value from 0 to 9. As simple as that. Here, because one character or one bit can take only 2 position and we need 8 networks, that is why we need 2 into 2 into 2, which is 8, means 2 to the power 3 is equal to 8, and these are the number of bits. And this is what you are exactly seeing here. 3 bits are same here. 3 bits are same here inside a particular part, right? So what is the meaning if I say this part number 4 is 01100/3? What is the meaning of first thing first, this /3? The meaning of this slash, there are two different meanings of this /3. The first meaning is whatever the range was, right? I used starting 3 bits to partition it. And if I'm using 3 bit to partition, it means that how many partition would have been there? There would have been 8 partition. And I am part of just, and this I am talking about, this is just the single part, right? The second meaning of this /3 is that the starting 3 bits should be fixed. Interesting. This should be like this in this part only, right? It means that these are the variable things. It means that these can be changed. Means this is fixed. You can change this. This can take 4 values, 0, 1, right? Sorry, 0, 0, 0, 1, 1, 0, and 1, 1. If these are fixed, then basically we can calculate the range of this part. Starting is here, ending is here, as simple as that. You can take any part. So try to understand, we can write any part in this format. And we have written the same thing in IPv4 addresses also, right? For example, if I talk about 192.168.10.0/24, the meaning is the starting 24 bits are used for network. Whatever the network range was, the starting for 24 bits are for, and then we can change this AND, right? And this 0 basically is not single 0. If I write in binary, this is going to be 0, 0, 0, 0, 0, 0, 0, 0, means 8 bits. How many combination, how many hosts we can have it? 2 to the power 8 is equal to 256, which is correct. Means I can have addresses from 192.168.10.1, then 10.2, then 3, then 4, then 5, right? As simple as that. We are not doing anything new, but try to understand again here. The meaning of /3 is to whatever the range was, I have used 3 bits to make little parts of it. 3 bits means 8 parts, right? And then the other meaning is that these 3 bits are going to be same in that part, right? And try to think that with these 3 bits, means I have 3 positions, right? Which I am saying these are going to be used for partition. And if I have 3 position, I can have 8 combination with them, and that is why I am having 8 different parts. I am repeating it again and again so that it can get into your mind, so that you can understand this board, right? And what is this board? Whatever I have written right here is, guys, just try to understand, this is the complete range of IPv6 addresses, complete range of IPv6 addresses. Interesting. How we can calculate the complete range of 32-bit addresses which are IPv4? There is no doubt about it. We can start from 0000 and we can end at 255.255.255 0.255 from 0000 to this. Here we are starting from 000, absolutely. But here we are ending at FFF. Why? Because this is written in hex, right? In IPv4 case, every octet cannot be more than 255, right? Because it's 8-bit. 8-bit you can represent only 256, means 0 to 255. That's why we write 255 here, right? But in hex, the maximum number is all F, or basically F, 16. That is why I have put all 16 here, means all F here. This is the entire range of IPv6 address. Now suppose, means I can take anybody from here. Suppose I'm taking Mr. Ankur Mishraji. I say, Mr. Ankur, I want to give you a problem here, right? You are the whole sole owner of this entire IPv6 address range, and you need to cut this entire range into 8 different pieces. What would you do? Then Ankurji said, that's very, very simple, Vishnu. If I presume this chocolate from here to here, right? Actually, this chocolate is my entire IPv6 address range. And what I'm going to do, I will be partitioning this chocolate into 8 different pieces. Piece number 1, piece number 2, 3, 4, then 5, 6, 7, and 8. As simple as that. We can do that. But this is philosophical answer. How we are going to do this with respect to these numbers, and it is going to be an interesting discussion, right? So first thing first, just try to understand, if I write these are 8 hex state, right, and I have written in one hex state only 10, it means that with the rule I just didn't write the starting 3 zeros. As simple as that, right? But this single 0 means 4 zeros of hex. And then if I talk about the single 0 in binary, right? Because we want to reduce the number, what was the number? We have, instead of 10, we have 4 zeros. Then instead of this 0, we have 4 zeros, then again 4 zeros, then again 4 zeros. This is the binary equivalent of this single 0. And if I talk about all F, if I take one F, right, it is going to give me 4 ones in binary. Another 4 for the second F, another 4 for the third F, and another 4 for the last F, means fourth F. So these 4F can be represented with 16 ones in binary. Then again 16, again 16. How many times? 8 times. Just try to think. Now, if we are thinking in binary, just do not think it as a single 0. These are 16 0. Just try to think about it, right? And now these people who were wholesale in charge of this IPv6, means one such authority is IANA, right? Now they are saying, no, we are not going to give this entire range to somebody, right? We will be dividing it. Maybe we can divide it into 2 pieces. One piece I can save for later purpose, and one I can distribute. As simple as that, right? Or maybe we can divide this into 8 pieces. We can hold on for 6 pieces, and we can give away for 2 pieces, right? Interesting. We can definitely do that. So these guys have decided, now we would like to divide this entire range of IPv6 addresses into 8 different pieces. And they are saying, these are my 8 different pieces. This is So, enjoying learning? If you have reached till this point of the video, I think you are enjoying learning, and I just do not want to waste your time. I would like to say that if you want to see this complete course, this course is available on my website, which is www.bridgewhy.com. Please have a look at it. And along with this course, there are so many other courses available. If you want to start your networking journey from the beginning, from the scratch, or if you are a seasoned networking engineer, please have a look at this website. So you can see here is my website. The link of this website is also available on the description area just below this video. Thank you so much and enjoy learning. This is piece number 1, this is piece number 2, this is piece number 3, this is 4, this is 5, and this is 6, and this is 7, and this is 8. Interesting. See, whatever the logic we had used, I will be taking the same logic to explain how they have come up with these 8 different parts. If you get it, perfectly fine. And that is what I am saying, that if we have distributed this into 8 different parts, one part is representing 1/8 of total IPv6 address. Same pizza example, right? We have 8 different pieces. One piece is representing 1/8 of total pizza. Simple, right? Now, let's talk about what is the meaning of this : 3, right? Let's take this green pen, and now we are solving this, that how : 3 is actually representing the 1/8 of total IPv6 address range. Very, very interesting. If I write : 3/3, it means that these 3 bits are used. 3 bits are used for what? These 3 bits are, as I mentioned in the previous board also, there are 2 purposes. One is we need to divide the entire range into 8 pieces. How many bits we are needing for that? How many bits we need for that? We need 3 bits, because 2 to the power 3 is equal to 8. Simple, right? And second thing is that this 3 are the bits. It means this in this address, : starting 3 bits should not be changed. You can change anything after that. Interesting. But then you are thinking, Mr. Vishnu, what is this : I am saying this is complete IPv6 address. And then you must be thinking, what? Is this an address? Yes, because it represents all zeros. Means address which is having all zeros in all the hex states. How many have written? 3 plus 4, 7 and 8. If I convert it into binary, right, it is going to give me, this is not a single zero in hex. These are 4 zeros in hex, as I mentioned. So these are going to be my 16 0. 1 2 3 4, 1 2 3 4, 1 2 3 4, 1 2 3 4. Then first column, then again all zeros, then second column, again all zeros, another column, 8 times you need to repeat. And then at last it is going to be /3. This is the actual number in binary. What they mean to say from this? They are saying the starting 3 bits should be same in this portion. This is the portion number 1. If that is the case, then it means that from 4 you can change it to 0 or any combination to all the digits, right? And that is how you are going to get the entire range of : 3. What should be the entire range of : 3? If I may write here. If I write here, the entire range is going to be, first of all zeros, right? It means that from all zeros, 0 : 0 : 0 : 0 : 0 : 0, I have converted back into hex. 3 5 0 : 0 : 0 8 to what? To all f, right? But I cannot change the starting 3. It should be 0 for sure, but I can change it 0 to 1. There are only two combinations here, 0 and then 1, as simple as that, right? Then what this number is going to be? This number is going to be 1 in hex. It means that this is going to be 1, right? And then what is the maximum value you can have? You can have the maximum value if you replace all these with f. It means that from 0 colon 0 colon 0 colon 0 to to 1f f f colon f f f colon f f f f colon f f and till 8 hex state. Very, very interesting, right? So guys, if I write colon slash 3, the meaning is this address range from 000 to 1, right? This is the meaning of colon 3. If I do the same mathematics, what is the meaning of 2000 colon 3? Again, let's do it. If I write 2000 colon 3, I will be writing only one hex state. Ankurji, I am coming to you. Don't worry. I have seen your hand raise. Now I will be talking about 2000 colon slash 3. What is the meaning? The meaning is simple. Starting 3 bits should be same in this portion of the address, in this partition of the address. How are I going to write 2 in binary? It is going to be 0 0 1 0. Then all of these are going to be 0 0 0 0 0 0 0 0 0. What I have done, I have written 2 here, this 0 here, this 0 here, and this 0 here. And then of course after that everything is 0, right? And then this slash 3. What is the meaning of this slash 3? The starting 3 should be same in this. It means that the starting number is going to be this, the ending number is going to be 0 0 1, but I can change this from 0 to 1, right? And then everything 1 1 1 1 1 1 1 1 1 1 1 1. If I change it to, and of course everything else also 1 1 1 1. It means that this will give me a number. If I convert it back to if I convert this back to binary, it is going to give me 2000 starting from this, and then end number is going to be, this number is, by the way guys, 3, right? When you put 0 to the 1, this is 2 plus 1 3. It is going to be 3 f f f colon f f f till 8 hex state. I know the mathematics is too much, but it is very, very simple if you have understood. It means that out of these 8 means if we have to divide these range 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, A, B, C, D, E. This is how these addresses are going to start. All IPv6 addresses, right? From 0 to to F. And how I am dividing them? I want to divide them in the 8 pieces. So this is my first piece, this is my second piece, which I have written from 2 to 3. Then 4 to 5 is my third piece, fourth piece, fifth piece, sixth piece, and 8th piece. As simple as that, right? So this is how these guys has divided these IPv6 address range. Ankur Mishra ji, please ask your question. Please go ahead.
Yes, Vishnu, like you say, /3. So, only first hex state, all digit means initial 3 digit would be 0.
Initial, not 3 digit. Initial 3 bits. I am talking about binary.
Here. Okay, yes, 3 bits. Sorry. So only 3 bits initial octet will be 0, not other the hex state.
No, right. We can see how we calculated this range from 000 to FFF. First, to the starting number is going to be, see, if I say I have 3 decimal numbers, I have to write what is the shortest number I can create from these decimal numbers. I can write 000. It is going to the shortest, right? Ankurji?
Right.
Then if I want to
Right.
write the highest maximum number, then I have to write the highest value this number can take. This is 9,
9.
this is 9, this is 9. And here I have put hex zeros and hex highest number, which is F. So this is the range which I am coming to, right? Now if I have divided this range, and this range is going to be started from 0 and will be ending at all F. Do you agree with me?
Yes, yes.
Right? So of course this starting 1 should be then after 0 to F and everything, right? It means that if you see all these addresses, I have divided into 8 pieces. 0 and 1 was here. Which number which was starting from 0 to 1, which means starting from zeros and ending at 1 means all F. 1 after 1 all F, and then basically number which will be starting from 2 to 3 here, 4 to 5 here, 6 to 7 here, and that is why the total number. And by the way, if this is E, then the F is just below it. E00002 to all Fs. Okay. I know there are going to be some confusion, some problem while understanding this logic, but this is what it is. And I am absolutely sure, because when I was searching over this on internet and many other places, I couldn't see this. So this is whatever you are reading. I think this is, we are reading it first time, right? I couldn't find it on internet. So means I feel really good that I was able to decode this message, that how the entire IPv6 address range is distributed into these 8 pieces. Of course, IANA people, of course, knew all these things, right? But I got to understand it, and if I get to understand it, I make sure that you all get it. Now, let's talk about this logic again, right? So, can we say that the entire IPv6 address range is written just here? This is 000::3, which is the starting 3 bits are this, right? This is my first partition. This is my second partition, and this second partition is known as Global Unicast Address, and this is the address range 2000::/3, which is in use right now. IANA is saying that this is the 1/8th piece of entire IPv6 address range, and we are starting from this. It's a huge range, believe me guys, right? Then this third piece is there, but we are not using it now. It is reserved or unassigned. Fourth piece is also there. Here, these are all unassigned. We can anytime use them whenever there is a need. But believe me, for the longest period of time, we won't be able to finish this range. Try to understand how many IPv6 address are here. If I talk about 2000::3, it means that these 3 bits can't be changed, right? But we can change the remaining 125 bits. It means that from 125 bits, we can make 2 to the power 125 addresses, which is huge, guys. Right? Interesting. Now, I think if you get it, now you must be thinking, Mr. Vishnu, but we have seen some address which are starting from it. Yes, right? And these addresses are here. If I say E is here, F is also here, and there are some addresses, some are reserved, but some are used as the multicast addresses. We will be talking about multicast addresses. Do not worry about them, right? And these addresses, as I mentioned, which are available 2000::3, these are known as Global Unicast Address. These are your equivalent to IPv4 public address, as simple as that, right? Every address inside it, mean 2 to the power 125, is routable over internet, and every address which you see unassigned also, it is going to be routable over internet, right? our 50% of the traffic is right now running on IPv6, right? And we are having a huge address space which is still remaining from this block. Means we are not using any unassigned addresses at all, right? To give you the perspective that if I say that if I have 232 to the power 32 IP addresses, and it is very, very interesting question for all of you, right? This is my entire range of IP addresses, which is 4.3 billion or 430 crores, right? If I say I have another address range, which is 2 to the power 64, how many addresses are going to be in it? Then you must be thinking, Mr. Vishnu, why are you asking this straightforward question? 2 to the power 32 means 4.3, 2 to the power 64 means 8.6, as simple as that. I would say no, this is not the case, right? 2 to the power 64 means it is 2 to the power 32, right, into 2 to the power 32 means 4.3 billion, right, into 4.3 billion, again approximately 16 billion addresses, right? Am I right here, guys? Is it okay? Perfect. Okay, so but interestingly, 2 to the power 32, again 4.3 into 4.3 billion. Yes, it is billion. That's okay. Yeah, perfect. Now let's see. But I am little bit confused here, right? Anybody would like to say that this calculation is not that right, Mr. Vishnu? Anybody? Or do you see any problem in this calculation? Because if I say 2 to the power 33, it is going to equal as 2 to the power 1 into 2 to the power 32, right? 2 to the power 32 means 4.2 billion, right? Multiply by 2 here, it is going to be 8.2. With this logic, if I multiply 4 into, this should be equal to 2 to the power 2 into 2 to the power 32 should be this number. Where I am doing the mistake, I have figured out if there is a mistake or not. I would ask this, just do this mathematics and just let me know in WhatsApp group where I am wrong, if I am wrong here. Okay, it's a homework to you. Very, very interesting homework, by the way. So now let's talk about how these numbers are distributed, or maybe we can discuss it after the class. So just see now how these numbers are distributed now, right? So if we talk about IANA, this is the highest authority, and we have given this highest authority a job, and that job was now distribute these IPv6 addresses to people. And there are 4 different type of customers now for this IANA. And you all know IANA was the organization which was totally distributing IPv4 addresses in highly illogical manner. So this time IPv6 guys said, please do not waste these addresses just like you did in case of IPv4. Have some logic. Make this process efficient, right? So first of all, I am taking an example from your IPv4, that suppose this IANA has divided these 2 to the power 32 bit or 2 to the power 32 IPv4 addresses into 8 parts. If it is done that way, then basically we have how many If it is done, then it is using 3-bit for these 8 parts, right? It means that we are going to have 8 different such addresses. 32.0.0.0 means we have 0 to 31 range in first part. Second part is going to be 32 to 63. Third part is going to be 64 to whatever you can calculate, and so on. And last part is going to be till 255. So there we are going to have 8 different parts. We have won this part, and now we want to distribute it. Definitely we cannot give it to only single registries, and that is why we need to break it down further, and that's what they are doing. So we have 5 internet registries, regional internet registries. One is responsible for Asia, right? Of course I cannot give the 1/8 of IP address to only one registry, right? And that is why I have divided it. I have divided this range into another 5 2 to the power 5 parts, means 32 parts. It means that one is 32.0, another one is 32.1, and so on. So it has given this 32.0.0.0 to ethnic, which is my Asian registry, which is responsible to deliver these addresses to all the guys, to everybody in Asia, right? See, this is changing. This number is changing from 3 to 8. If I talk about 8 here, then 8 bits are fixed. You cannot change them, starting 8 bits. But 24 bits are free. And then you need to divide them further, because in Asia, there are going to be number of service providers like Airtel, like Geo, and so on. As simple as that. When they distributed it, they are saying now there are maybe many service providers. Suppose there are 200. So they decided on 8 bits to make 2 to the power 8, means 256. So they can distribute this to 256 ISPs, DCs, these /16. Interesting. /16 means starting 16 bits are fixed, don't touch them, but the remaining 16 bit you can use for your customers, and these customers are home users, enterprises, cloud providers, and so on, right? So they are getting at /22. This is what you get, sometimes /24 if they do not have the address. But try to think, we were started from /3 to /8 to /16, and then at the end 22. What is the meaning of starting 22 to bit you do not touch, right? But the remaining are your address, means 10 bits are means 2 to the power 10 means you can have 1024 addresses. You can further subnet it accordingly, right? If you have 3 or 2 subnets, you can make a subnet of 500 and 500, and then you can work. This was IPv4, an example. It is not that exactly it is going to happen like this way, but now we are talking about IPv6, and we are talking about that IANA is saying I am going to give only 1/8 of the total range. Other 1/7 are still with me, and that range is 2000:3. This is known as my global addresses, global unicast addresses, right? Now, if I want to distribute them to this regional registries, there are 5 regional registries, 3, 4, 5, right? I can divide this easily into 5 portions and give it to them. But IANA this time is really, really efficient. They are saying, no, these are huge numbers. Maybe I can give regional interest these addresses again and again. So what it is doing, it is using 9 bits, next 9 bits to partition this number, right? And if you use 9 bits to partition this number, it means that it is going to be 2 to the power 9. The meaning is 512. So this range they have divided into 512 different parts. And out of that part, they are giving only one part to ethnic, which is say 2000:3 colon colon 12. Similarly to this one, maybe 2001, 2002, and so on, colon colon 12, right? But the interesting point is that out of 500 partition, they have just given 5. It means that if these regional internet registries are going to say my addresses are over, they can again go and they can again assign, means it can assign these addresses 100 times. But believe me, this number is again huge, 2000 colon colon 12. They have assigned this to ethnic, and now Geo is saying give me IP address. I would like to go, as you all know, 95% of Geo is already on IPv6 address. Mobile users are already on IPv6 address. So Geo must have gone to this happening and they're asking for this. Now they are using its brain. Regional Internet Registry happening. They are saying /12 is really great number and I have so many ISPs. So what I would do is I would use 20 bits to further partition this. Very, very interesting, right? 20 bits, guys. 20 bits means 2 to the power 10, 2 to the power 10, sorry, 2 to the power 20. 2 to the power 20 means 1024 into 1024, as simple as that, right? Interesting. These many partition regional internet registry which is ethnic is going to do, and out of those it is going to give you only, or Geo only one, means it can cater these many different or big customers, big internet service providers. Now we have this colon colon 32, right? And now we have the home users, we have enterprise users, we have cloud users, right? So suppose a school or university goes to this ISP and it asks for an IPv6 address. And they are saying, okay, we have a /32. They are going to this Geo or maybe Airtel, right? And they are saying, there are many such customers with me. So I will be using, right, another 16-bit for these customers. 16 bits means 2 to the power 16, which is 65,536. So this guy, ISP, can cater these many customers, right? And it is giving them this IP address of colon colon 48. I'm not saying only 48, it can give till 64. But try to understand, it is giving you, the college or university or enterprise, is /48. Suppose it gives you only 64, right? That this is for you. It means that you can use the remaining 64-bit for your hosts. And interestingly, 64-bit means 2 to the power 64. Again, a very, very big number, means 2 to the power 32 into 2 to the power 32. Means 2 to the power 64. Simple, right? Huge number, way, 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 way more than your entire IPv4 range you are getting in this single network which is assigned by Geo to the end customer. Interesting, right? Any doubt, any question? I think we are good. Now, we would like to talk about this GUA, right, or Global Unicast Addresses structure and little bit of subnetting. As you all know, that my ISP was assigning me /48, right? Interesting. And this /48 contains the starting 3 bits which are fixed, 001, you remember? And then basically next 12 bits or the 9 bits were used by regional internet registries, right? And then 20 bits again was used by other authorities, and then 16, or these are combined. If you combine them, these are going to be 32, And out of 32, if it reaches to geo, it is going to give basically, if it is going to give this school or the university, it is going to give as a /48 by dividing this number into 2 to the power 16 different parts. If you don't get it, just see the previous poll. Basically, I get, means if I am the school, I will be getting this IP address, suppose 2000:/48. This is your range, Mr. School. So when this school reaches to IANA, and this school is asking, I am not asking IPv4 addresses. Give me IPv6. IANA is very, very happy. Or you can say, this guy is going towards the RIR, Regional Internet Registry, which is ethnic. This school is in India, and ethnic will be assigning this range to it, /48 range. Interesting, right? Later in this class, you will come to know that if I have a computer, if I have a router, right? This computer is going to get, right? It can automatically configure the interface address. Last 64-bit, it can easily calculate. There is an algorithm called EUI 64. And that is why we keep these 64-bit for interface ID. Means for, because these routers, these hosts can easily calculate these 64 bits. And the total number of IPv6 bits are 128. Out of this, 64 bit are for interface ID, 48 bit are for the global routing prefix, which I got from Geo. How many I am still remaining? I am still remaining with 16 bits, right? I'm still remaining with 16 bit. With these 16 bits, I can configure 2 to the power 16, right? Or I can make 2 to the power 16 network or subnets or VLAN for my little school. 2 to the power 16 means what? It means 65,536 VLANs, guys. And every VLAN is going to contain 2 to the power 64 bits. Means I have these many network. Every network is going to contain 2 to the power 64, which is way, way, way more than your entire IPv4 range. See the level, see the scale we are talking about here. Interesting, amazing, guys, right? Now let's see an example. Suppose we have 192.168.10, right, .0/24, and if I want to divide this number into 4 pieces, right, of course, for dividing this number into 4 pieces, I need 2 bits, right, or 4 network, I need 2 bits. It means that we will be having these 4 subnet, 192.168.0/26. The second subnet is going to be 192.168.10.64/26. Okay, 4, and then basically, yes, then 192.168.10.127. Okay, 128.26, and then .191.2/26, right? These are going to be my 4 subnet, 1, 2, 3, 4. And every subnet is going to be how many addresses? Total 32. 26 are gone for the network, means 6, means 2 to the power only 64 hosts I have in every network. Now, by default here, if you don't do anything, guys, try to understand 64-bit is host portion. Way, way, way more than your entire IPv4 address range. So people ask that, can this subnet ID be different? And I say yes, right? It depends on how much you ask for from this regional internet registry, right? Previously, you asked for a /48. Generally, they are going to give you /48, so that you can use /16, the next 16 bit for your subnetting. And this is fixed, right? 64 bits are fixed. But now there is a big university, or maybe big one, right? And they are saying, no, I do not want to have only 65,536 subnets, maybe more than that. Although this is huge, guys. If that is the case, your ISP Geo is going to say, or Airtel is going to say, okay, that is fine. What I can do is I can give you /32, right? Make sure this is your 64-bit. It is fixed. Now you have another 32 bits for what? You have 32 bits for subnetting, for making partition out of this big range. It means that how many networks you can have, how many VLANs you can have. 2 to the power 32 means the number of total IPv4 addresses you can have that many as your number of networks, and every network is going to have 2 to the power 64 hosts. See the level, see that scalability, guys, right? Very interesting. And try to understand, I'm not joking about it. IANA, right, has one regional registry for America, regional internet registry, and this registry have assigned a /32 for University of California. Believe me, you can check on internet. Interesting, right? But see, we are in the mindset of from IPv4, we want to save as much as IP addresses, right? But it is not the case here. By default, you are going to get a VLAN in which 2 to the power 64 addresses can be there, right? But here is my problem, right? Here is my problem. If that is the case, then it is okay to have a 2 to the power 64 or maybe /64 network here, right? In this VLAN 2001::64, in which we have 2 to the power 64 hosts. That is fine. But it is really interesting to see what is going to happen only on this link. There are going to be 2 addresses on this link between 2 routers. We call them infrastructure links. Do we need to have a /64 for this? Do we need to have 2 to the power 64 addresses on this link? No. And these are the links where you can go and take bits from your interface ID. As I was mentioning, interface ID is fixed for 64-bit, but yes, you can change it for your link. But why there is a requirement that my interface ID should be, or interface ID should be of 64-bit length, right? And the reason is, as I mentioned, that these guys, these laptops can configure the interface IPv6 address on its own. They can calculate the ending 64 bits on its own, and the remaining 64 bits are the network numbers which are there, right, which you will get from your network provider, or maybe your network engineer. If you combine them, it is going to be 128. So this is the automatic address assignment feature of IPv6, which need 64 bits, which can calculate 64 bits, right? You do not need to be worried about it. But of course, on the infrastructure link, if we talk about IPv4, if we talk about R1 and R2, which are connected like this, what range we use? We use 31 range, /31, which says that there are going to be only 1 bit for host. 1 bit means 2 to the power 1, means only 2 addresses. If that is the case, 1 address is here, 1 address is here, right? That's it. Can we use something like that in IPv6? Yes, for the infrastructure links, you can go till /127, only 1 bit for host address. 1 bit means 2 to the power 1, again 2, 1 address here, 1 address here. For infrastructure link, it is wise to take the bits from interface side, right? Interesting. Now, I would really like to talk about local IPv6 addresses, but this is where I stopped in Hindi class. But right now, what I would say is whatever is coming to your mind, whatever is coming to your mind. I know the session was quite heavy, lots and lots of maths, but believe me, guys, it was easy math. Okay, Arun has a question. Arun ji, please ask. Whatever is coming to your mind, I am free for questions. Means next 10, 15 minutes, whatever is coming to your mind. Mr. Arun, please go ahead.
Yeah, Vishnu, my question is related to that, dynamic IP address on the machines.
Yeah.
Okay. Let's say, we assign an IP address to one of the organization, and how come the laptop or device knows that, it's part of that particular network?
Yeah, so these things are still unanswered in this course, right? And there are going to be two different sessions on only this thing, right? So basically, whenever we have this router and when we configure an IPv6 address here with its mask, there are some messages exchanged, and these messages belong to a protocol which is known as NDP, Neighbor Discovery Protocol, right? Out of these messages, basically this host will get the starting 64 bits from here only. It is advertising the subnet, and it can calculate the 64 bits on its own, which is going to give it a unique IPv6 address 128 bit. How this happened? Do not worry, we are going to talk about it.
Okay, thanks, Vishnu.
Okay, so there is going to be two different classes on this. It's a very important piece of IPv6. Anybody else? I think somebody has raised the hand. Vignesh, please go ahead. Mr. Vignesh?
Yeah, but can you go to third board?
Third board. How do you remember, man? That was the third board. I think you have written the written side somewhere, right? This is fourth again.
So
this is fourth again. Interesting.
So,
very nice.
oh,
yeah,
okay.
good.
Then this only. Yeah. Sorry. I think the next board.
Oh, the next board. This one. Okay.
Yeah. So the interface ID you told like it can be 64 bits, right? And it can be changed. So it cannot be more than 64 bits, or how is it? Like maximum it can be only 64 bits.
See,
or depending upon the requirement.
Yeah, it can. It should not be more. See, we are already having too much of host addresses with 2 to the power 64.
Yeah.
Right? So it should not be more, but it can be less. In case of infrastructure link, but do not try to do it on the networks where your machines are there, right? The reason is, if you do that, then it is going to break one of the most important feature of IPv6, which is plug and play. Through plug and play, they can calculate the last 64 bit of their address, and the initial 64 bit is provided by the router. How it is happened, it's one interesting story. Vignesh.
And one thing I just wanted to check my understanding. Let's say our university gets /32 address from the ISP.
Perfect.
So, and we have remaining 96 bits. So
Yes.
out of which 64 bits will be part of interface ID.
Let me write.
So
let me write. 32 you got from your ISP, right? Just
Yes.
like University of California did, right? Then
Yes.
/64 bit is for interface ID, right?
Correct.
And
So,
then remaining
that
is 32.
means
Yes.
32. Yes. So that means we can have 32 different, 2 power 32 different types of VLANs, each
Yes.
having 2 power 64 machines, right?
Yes.
Or 2 power
Yes.
64 unique IDs.
Yes.
Okay.
Huge, right?
Yeah.
See, I wanted to spend this much of time so that you can understand the scale. We were talking about this again and again, that on entire Earth, if you put the sand, if you take one piece of that sand grain, you can assign 1,000 or lakhs of address to this grain. This is the scale of IPv6. Okay. Anybody else?
Yeah. Thank you.
Anyone, guys? Interesting. I would presume that whoever is not asking the question, they got it all. Or maybe they are deciding right now that we have to go through this recording once again. But believe me, leave about others, that what will other think. If you have any doubt in your mind, please do ask. If I have written some, as I mentioned, this is the benefit of live classes, right? So, and this is how the people who will look these courses offline, they will get the understanding, because whatever is coming to your mind, maybe that is also coming to their mind also in offline mode, but they couldn't ask question. You can ask the question, right? So I would like to end this class, means if there is no other question, with an interesting fact about IPv6, right? And that fact is that suppose I have a PC and it is having an interface. So what used to happen in case of IPv4, right? Or maybe a router which is having the 0/1 interface. I just go into this interface, right? Country, and I write IP address, say 1.1.1.1/24, right? This is what I do. Maybe I want to change the IP address, so I easily go and write without doing no. I will write IP address 1.1.10.1 or 10.10/24. This IP address will be gone and this will be here until unless I specify this is a secondary IP address, which I don't, right? So mostly in case of IPv4, we have only one IP address configured per interface. It is not the case. It is not the case with IPv6. A single interface can have more than one IP address, IPv6 address, maybe 3, maybe 4, maybe 5. Why do we have them? We will be talking about in the next class, but this is one of the most interesting fact in IPv6. Anybody, any doubt, any question, I am here. Otherwise, we can end the class. Next class is going to be on Monday at the same time. Anyone? Okay, at least tell me you are able to hear me. At least give me the thumbs up.
Yes, Vishnu.
Perfect. Again, I'm saying again and again, please do ask if you have anything in your mind. Okay, perfect. See you guys. See you in the next class where we will be, means this is the most, if you say the entire course, this was the most difficult class, right? And if you get only 40% of it, if you watch the recording again, you will be getting the 100% of it for sure. Next classes are going to be really, really easy, whether it's NDP, whether it's transition technology, anything. This is the class which I think is difficult for a newbie. Having said that, bye for now. See you on Monday.